It's Friday, and my phone is telling me that I'm having conductivity issues, but I've been having conductivity issues for 3 weeks, and I just got off of the phone with AT&T, obviously not this phone, and the towers are still down in the Humble, Texas area and will not be repaired until next week. So if you're trying to reach me by phone, this is why I'm not answering. I'm not even getting your messages, so there is that. But today we want to talk about using nanotechnology, which is wonderful. I love nanotechnology, but this is nanotechnology in the form of gold as an antibiotic. Now, I know that silver is a natural antibiotic, and we use that here in the clinic almost every day. I have liquid silver and silver in a gel at my home, and I use it frequently. If I get a scrape, I'll use the gel. If I am around someone with pink eye or whatever, I'll use it in my eye. It is something that you can just use anywhere. When I travel, I'll take a tablespoon before I get on the plane. I'll take a tablespoon when I get off the plane. I'll take a tablespoon when I get to the hotel, because all these places are just rife with germs. So we know about silver, and we know that silver works really well, but there's some new research that has come out about using gold nanoparticles, and I'm just thinking, well, that would be kind of cool to do that, but they don't know if there's any toxicity to that. So we're going to be talking about this kind of technology. Now, why do I like this technology? Well, I like this technology because silver and gold, they do not have any kind of adverse effect on the beneficial bacteria that we have in our bodies. So our bodies are made up, should be made up, okay? So depending on where you live and how you operate, you should optimally have 80% good bacteria in your body and 20% negative bacteria in our body. We're going to have negative bacteria because we just don't live in the Garden of Eden, okay? But if we have that 20%, we're going to be just fine, and we're not going to have any sickness and disease. However, when we are exposed to antibiotics, and even if, like me, you've never taken antibiotics in 20 to 40 years, that's me, you still are getting antibiotics in your food. You're getting them in your meat, in your poultry, in your dairy products. All right, even if you get organic, right, when you go out to eat and that kind of thing, you're probably not getting organic unless you're at really top drawer restaurants, and even then it's a little bit suspect. You're still getting the antibiotics in those foods. So when you're getting those in those foods, then your body adapts to those antibiotics and they become antibiotic resistant. So the good thing about the silver and the gold is that the bacteria has never seen that before, and so they don't have any kind of cloaking mechanisms or adaptive mechanisms because they've never seen that. So that's a really, really good thing. So scientists have developed this new type of technology, and it is laser heated gold nanoparticles. Now, they use this to both visualize and destroy bacterial biofilms. And we're going to talk about biofilms in a minute, but this is also technology, just like a sonogram or a CAT scan. I'm not exactly sure how it works, but it goes in there and it shows you what's going on as well as destroying the biofilm. So this has only been tested on rodents and skin wounds, all right? So hopefully this is going to come to the public really, really soon, and we'll be able to add this to our arsenal that is very, very healthy and won't absolutely decimate our gut. So this is happening in the University of Pennsylvania and Stanford University. They have developed this technique to use sugar-coated gold nanoparticles. Now, I don't like the fact that they're sugar-coated, but, you know, I'm not the scientist, and maybe there's a reason for that to happen. So when these nanoparticles are heated with near-infrared lasers, the nanoparticles can both show and destroy the biofilms in infected teeth and skin wounds of rats and mice. Now, biofilms are made up of tiny living things that cling to the surface. These surfaces can be non-living, such as in rocks or streams, or they can be parts of animals, us included. We most often find biofilms in the GI tract. Yes, you have them. Yes, if you've been sick a long time, you have a lot of them, and there are techniques that we can use to go in and destroy those biofilms, and this is really important. Now, this study was published in the Journal of Clinical Investigation, and it demonstrated that the dual purpose of the nanoparticles' diagnostic and therapeutic potential in eliminating entrenched bacteria and viruses. Now, you may know, you may not know, we all have, as part of our microbiome, we all have bacteria, we all have viruses, we all have fungus, and we all have parasites. All right, that's part of who we are. Now, when we have a very, very strong immune system, our immune system keeps those invaders in check. When our immune system plummets for whatever reason, then we've got issues with that, all right? We have developed a highly innovative and clinically translatable infectious treatment technique, says the lead author, Mary Ann, and I'm going to mess up this last name, but I'm going to try. But we're going to call her Mary Ann from now on so that I don't butcher her name. It's Heil-Mealey. Okay, hope that's right. She holds a doctorate in mechanical engineering. She says these nanoparticles are a rapid, drug-free method for wound and skin infection imaging and treatment. It is a new way to clean teeth and wounds using tiny gold particles and light. So I'm all for the new treatment because I hate going to the dentist. I hate that drill. The sound of the drill gives me, just the heebie-jeebies because I went to a dentist as a child who hurt me every single time. And so it's like an act of God to even get me to go to the dentist, which I do go. I go to a holistic dentist that does not hurt me. So maybe he does this gold technology. I don't think it's really been approved here in the United States, but maybe it's coming. I know he does use lasers instead of drills, so this is a good thing. She says, Marianne, this is the first time that we have used engineered gold nanoparticles to eradicate oral biofilms using photothermal therapy. According to Marianne, these particles work quickly, killing the harmful bacteria in less than 1 minute without broad spectrum antibiotics. Because they work so well, the scientists may be able to make new products such as special mouthwash, sticky strips, or bandages that use light to clean wounds. Now, we do know that the bandage industry has become better over the years. You can now get Manuka honey bandages. I don't know if you know that. You can also get silver bandages. They've got on the gauze part that goes on your wound, it is infused with silver, which we definitely like that. The research received support from several National Institutes of Health branches, including the National Institute of Biomedical Imaging and Bioengineering. With this platform, you can bust biofilms without surgically debriding infections, which can be necessary when using antibiotics, says Louisa Russell. She's the program director of the National Institutes of Biomedical Imagery and Bioengineering's Division of Discovery, Science, and Technology. That's a big mouthful, all right? This method could be beneficial for people who cannot take standard medication. It works even for those who are allergic to antibiotics or who have infections that don't respond to typical treatment. So this is one thing that we want to talk about because this hits home. I have a brother who had multiple exposures to antibiotics because he had contracted a parasitic infection when he was on a cruise. Went to medical doctor, did not understand all the things that were going on. And after multiple courses over a 6-month period, he developed C. diff. Now, you can die from C. diff, but you get C. diff when you've taken multiple courses of antibiotics and your body just kind of spazzes out and you get this horrible diarrhea and all that kind of stuff. And like I said, you can definitely die from this. And so this is one reason why we don't like traditional antibiotics, because this can happen. What else can happen, though, is if you have course after course of antibiotics, the bacteria that you have, and this is one thing that you need to pay attention if you take antibiotics. They say on the bottle, on the prescription, make sure you use this complete prescription. Most people don't do that. They'll do the prescription until they start to feel better, and then they say, oh, I'm well, and they put their prescription away because they're going to save it for the next time that they need it. But this is not the right thing to do, because what this has done is it has squashed whatever infection that you have, and yet it hasn't wiped it out, but you feel better, and so you think it's gone. But what happens in the meantime when you quit taking that antibiotic is that the germs start to morph and they become antibiotic resistant. And this is what we have in so many of our older generation. And I say that, I am older, right? And what we're having with our older people is that they have MRSA. You may have heard that word, and what that means, it is antibiotic resistant infection. And so they'll give them this class of antibiotic and this class of antibiotic and this class of and then on and on and on. And so the problem is with that is when they get to the top tier of antibiotics, and they're called levothyroxines, I think is what they're called. All of those, and your most famous one that you would know is Cipro, right? Those levothyroxines are, that's not the right word. Anyway, those class of antibiotics, they cause irreparable muscle damage. What is the biggest muscle in your body? It is your heart, right? And so you definitely don't want to cause muscle damage. Of course, you got your glutes and all those other things too, but we're trying to protect your body. And so you want to use that high class of antibiotics when you're in a really, really life endangering situation. So this gold nanotechnology is not going to have those side effects for you. The fact that this treatment is antibiotic free is a huge strength, says Russell, who holds a doctorate in materials science and engineering. Phytothermal therapy is nearly 100% effective at killing biofilms, as the study found. The treatment method is especially fast for oral infections. We applied the laser for 1 minute, but really in about 30 seconds, we have killed basically all of the bacteria. Now, when you are checking your teeth and that kind of thing, or you go to the dentist and they're cleaning your teeth and they'll say, oh man, you've got a lot of plaque. Plaque is a biofilm. You've got plaque, you have plaque in your heart, you got plaque in your teeth, you got plaque in your gut. All of these are biofilms, and so we don't want to have biofilms because biofilms are a nice soft bed for the bacteria and the viruses to cuddle down and have a long-term trip, right? And so we don't want to have that. We want to make sure that our biofilms are disrupted as much as possible. The researchers note that they hope further tests will show if this strategy can prevent cavities and accelerate healing. So to understand how this light-based therapy works, you first need to understand biofilms. Now, biofilms are communities of microorganisms that adhere to surfaces in moist environments, and they reproduce. They are slimy, right? So think of when you go to the lake. We here in Houston, we're just north of Houston, and we can go to Galveston. My husband likes to go to the dike, Texas City Dike. That's where he likes to go to fish. And so you can actually get off the bridge, park your car, get on the rocks, cast into the bay. The problem with the rocks is they have biofilm. They have algae. We would call it algae, but it's a biofilm. That algae attaches to the rocks, and it is nourished because it is in a moist, hot environment. And if you step on that algae, you're probably going to bust your bottom because you're not wearing the right shoes or whatever. So that is a biofilm, but we get that in our bodies as well. Biofilms can make up of a single or multiple species of microbes, including bacteria and fungi, according to the Microbiology Society. These structures enhance the microbial survival by providing support and protection against threats, such as antimicrobials and immune responses of the body, which are your macrophages and your phagocytes, everything in the lymphatic system. So biofilm, now I like this statistic, biofilm infections account for as much as 80% of all infections in humans. So if you have a chronic something or another going on, it is most likely due to biofilms in your body. And so when your body has biofilms, your immune system cannot respond and do what it needs to do to take care of the problems. 80% of infections are due to biofilms. They cause various issues, gum disease, urinary tract infections, and they can even attach to medical devices, including pacemakers and contact lenses. This is something that if you wear contact lenses like I do, this is why you must clean them regularly, because you're going to get those protein deposits on your lenses, and the protein deposits are in fact biofilms. All right, we don't want to have those biofilms. According to the Microbiology Society, bacteria biofilms can be 1,000 times more resistant to antibiotics than free-floating bacteria, making them a major cause for treatment failure. So this is really, really important. If you're dealing with an infection that you just cannot get rid of, then what you need to do is you need to ask me, what can we do about getting rid of the biofilms? Because we know how to do that. We've got products that will do that. Is it necessarily a comfortable procedure? It depends. It depends on your body. It can be comfortable. It can be uncomfortable depending on how entrenched the biofilm is in your body. A dense network of proteins and carbohydrates in biofilms can prevent the antibiotics from reaching the microbes. Biofilms are very difficult to treat with existing clinical therapies due to antimicrobial resistance, and we talked about that earlier. Studies indicate that biofilm infections, once established, cannot be treated by antibiotics alone in most cases. Therefore, a critical need exists to effectively diagnose and treat biofilm infections, all right? Biofilm infections are invisible to the naked eye. Nanoparticles measure from 1 nanometer to 100 nanometers. And so you've got something that you can't see. Now, you can see in your teeth, you can see the plaque if you've got a really, really heavy buildup. We don't have any kind of imaging that we can do, not being medical, that we can do to survey what's going on in the GI tract. But also the nanoparticles are very, very small as well. And so they are absorbed into the body. They are put into the body via light, all right? And they use near-infrared light. Now, near-infrared lasers emit radiation that does not damage the tissues and can promote cell regeneration and improve blood circulation, which promotes faster healing. This is why we have in the clinic an infrared sauna. It's got your far infrared, it's got your near infrared, and it's also got your mid-infrared spectrum. And so it promotes healing, it promotes the breakdown of biofilm, it promotes healing in all different areas. And so this is really important therapy to look at. Now, there's a lot of stuff on the internet that you can find that says it's red light. It may or may not be. It may or may not be of the right spectrum. So just use a lot of caution and do your research before you purchase those kind of things, because they're not cheap at all. Noble metal nanoparticles are microscopic particles made from noble metals, metals that are resistant to corrosion and oxidation in moist air. The most common noble minerals are gold, silver, and platinum. Now, we talked about silver. Silver is readily available and you can get it anywhere. Now, we have one of the strongest silver solutions, and it is 20 parts per million. A lot of the products out there that you get from your big box store are 10 parts per million, 5 parts per million, and maybe even lower than that. So you want to get a really, really strong solution if you want it to do what it needs to do. Gold is just not coming out. But we know about platinum because we know platinum is used in chemotherapy. Now, it's very effective for cancer, but it absolutely kills your immune system. And so this is why we are against it, because it kills your immune system. So my late husband, as most of you know, had cancer. and they wanted to treat him with platinum chemotherapy. And I told him, well, we looked at the doctor and we got all the statistics, right? The chemotherapy would probably be maybe 25% effective. 25% effective. But it would be 100% effective at destroying his immune system. So that means that if he took that treatment, if he had a hangnail, he would die of the hangnail because his immune system would be decimated, but he only had 25% of surviving the therapy and surviving the cancer. So we chose not to do that. But we do know about platinum being used in chemotherapy. So there is potential application, including drug delivery and thermal ablation, which uses heat to remove unwanted body tissue. So you may have heard of thermal ablation. They can do it in your heart. Women can have it done. They can have their uterus, have an ablation on their uterus. I'm not so sure I like that therapy because it actually burns the lining of whatever organ you're working on. And so do your research before you do that. I'm not so sure that it's a good idea. I've not done it. I've not been offered that therapy, but I know people that have and have had complications. So just make sure if that's something that you're being advised to do, that you do your research so that you get all the information that you can get. In a review article published by Frontiers in Chemistry, researchers from Malaysia, India, and Saudi Arabia note that the noble metal nanoparticles are used in antimicrobial agents because of their stability and biocompatibility. Their small size and high surface to volume ratio allow them to penetrate bacterial membranes effectively. Now, those bacterial membranes are your biofilms, all right? You don't want to have these biofilms. The metal-based nanoparticles seem to have a commanding role in 21st century because of their vital role in the nanomedicine and other biological applications. The nanoparticles can be fabricated by using several synthetic routes and effectively used in various nanomedical and biological applications. Now, normally, we don't want to do anything that is synthetically derived. However, you're not able to use metals in a biological formulation. Okay, you've got to use it in a mechanical synthetic formulation in order for it to work. So don't get kind of confused on that. Gold nanoparticles, which are non-toxic, are promising for photothermal therapy because they convert light energy into heat to kill the pathogens, according to the authors of this new study. They also emit ultrasound waves in response to light, enabling photoacoustic imaging, which is a non-invasive way to take detailed pictures inside the body using light. I think that's fantastic. And I mean, it's just amazing what lasers can do. And I really do appreciate laser therapy. So if you have an option to do that, that might be a really good idea for you. Scientists may be entering a new frontier in infection management and treatment that potentially rivals the discovery of antibiotics. Quote, as scientists, our goal is to explore innovative approaches to combat infectious diseases. This is from Marianne. We are excited about the prospects and look forward to advancing our research through animal studies and clinical trials. In addition to her work on nanoparticles for photothermal therapy, she and her colleagues are investigating alternative treatments to reduce antibiotic resistance, including phage therapy. Now, phage therapy is using the body's own mechanisms in order to chew up these biofilms and that kind of thing. So think back about 40 years ago, right, when computers just first came out and computer games came out, and there was Pac-Man. You know, you had this little round gizmo going across the screen, eating up all the black dots, right? Well, that's what your phagocytes and your macrophages in your body, these are things that you have in your white blood cells, in your lymphatic system, that do with all of the bacteria, the fungus, the viruses, all that kind of thing. So this particular treatment that she's talking about uses bacteriophages, which are, in this case, viruses that are selectively targeted to kill specific bacteria. Now, About 30 years ago, we worked with a medical team, and they were using virus envelopes, which is a fatty, like a fatty cell, virus envelope, and they would put their therapy inside the virus envelope. The body would accept the virus, but when the body started to break down that envelope, the beneficial component would come out and do what it needed to do. And so that's kind of what they're talking about with this particular biophage treatment. Using a virus that's not particularly harmful to you, but it is a mechanism to get something into the body that can do something really good from the inside out. In her review, which was published in Wire's Nanomedicine and Nanobiotechnology, Marianne reported that complex metal nanostructures show promise for personalized treatments. While the USDA Food and Drug Administration approval for clinical trials is pending, preliminary results indicate that these nanostructures have high targeting capability, biocapability, and stability, making them promising for real-world clinical imaging and treatment, according to Marianne. Further research will investigate the nanoparticles' effectiveness against biofilm infections in catheters, heart valves, lungs, and prosthetic joints. So remember last week, we talked about it took $4 million to get an application to the FDA, right? If you are putting forth an application for a non-biological treatment that works, all right, what if this works, if this came to market and it worked, it would probably make the antibiotic industry non-existent, right? Now, does the medical industry, are they willing to admit something that causes no harm to your system to replace something, antibiotics, that do cause harm to your system? Now, we like antibiotics. We're thankful for antibiotics, but the problem is we get the overuse of the antibiotics. We get them in our dairy and our meat, as I said before. When we get these in the body, right, it causes our own system to mutate and we become antibiotic resistant. When you introduce something like a nanoparticle, what you're doing is you're removing that substance, the need of that substance, and you're able to get to the root of the problem, which is wonderful for us as patients. However, I'm very skeptical that the FDA would grant the patent for this, because if I had a choice, can I use nanotechnology or do I want to use antibiotics? I'm probably going to want to use the nanotechnology because I want to protect my own microbiome in my GI tract. Does that make sense? So this is information. It is out there. Maybe with the changes that are going on, maybe our food will get cleaned up. Maybe our air will get cleaned up. Maybe our medical opportunities will get cleaned up so that we're not going to be victims of over-medicating our systems with antibiotics and then developing antibiotic-resistant bacteria, or at the very worst, C. diff. So these are some considerations that are out there. I'm glad they are doing this research. I'm glad there is approval pending. I can't tell you I have really high hopes because I know how the medical system works. There are clinically proven cancer treatments that do not involve chemo and radiation, and they are banned, and you're going to have to figure out why. So that's kind of coloring my perspective here, and I'm probably going to get this video banned for saying that out loud, but there you go, I said it. So that's a lot of information. Nanotechnology to replace antibiotic therapy. I think it's a great idea. I hope it passes. I hope you guys think twice about antibiotics. There are natural herbs and supplements that you can use that are natural antibiotics. I mentioned silver. That is one, but there's all sorts of other liquid formulas and encapsulated formulas that go after viruses and bacteria. So you don't have to go to the doctor to get medical antibiotics. There are things that you can have in your kitchen cabinet, all right, that can help you as well. So thank you for joining me. It is the weekend. It's not really a weekend for us. We've got Music on Main tonight, and we've got the Sip and Shop. So if you are local, you want to come by the clinic. We're going to be open tonight from 4 till 7. And then we are traveling to Lufkin tomorrow, November the 9th, and we're going to take care of our friends in Lufkin. So it's going to be a couple of more days until it's the weekend for me. But I hope you guys have a great weekend. Relax, recover, replenish, do all the things that you need to do, because guess what? Next week is another day to go out and fight and win. Take care. See you soon. Have a great weekend.